Hi, I'm Jamie, and I've created this presentation to tell you all about the ins and outs of recycling plastics. Plastics are all around us. They can be found in clothes, cars, packaging, construction, toys, electronics, and more. There are thousands of uses of plastics, although they've only been around in industry for less than 100 years, whether synthetic, i.e. completely man-made, or semi-synthetic. Plastics are polymers. But what is a polymer? A polymer is a large molecule with a repeating unit. As an example, the repeating unit for polyethylene, otherwise known as polythene, is shown. Although all plastics are polymers, not all polymers are plastics. Plastics tend to be polymers with a high molecular mass. There are two types of organic, i.e. carbon-containing polymers. Chain growth, where the alkene monomers add on to the chain, like this, and step growth, where two monomers with reactive functional groups on each of their two ends can react, and a chain is formed as this process continues. Polyesters are step growth polymers, while polystyrene is a chain growth polymer. Polymers have a huge range of physical properties, meaning that they can serve a purpose in a wide variety of fields. They vary in strength, adhesiveness, conductivity, flexibility, and many other physical properties. In modern chemistry, they're being used in nanoscience due to this range of properties, and are excellent for replacing naturally occurring materials of limited supply and/or high expense in industry, such as some woods, tortoiseshell, and ivory. This seems to have been swept under the carpet rather well. Contrary to popular belief, these numbers do not give 7 types of recyclable plastics, but simply the most commonly used plastics. Plastics 1 and 2 are commonly recycled. 3 to 5 are comparatively difficult to recycle, or have dangerous side effects, as in the case of PVC, which is a threat to the environment due to dioxins and phthalates released when it's burned. Plastic 6, polystyrene, is becoming more easy to recycle, though because it doesn't weigh much for its size, the transport costs means you're not really getting your money's worth. 7 are almost never recycled, as these often contain mixtures of plastics that are very difficult to separate. There are 2 types of plastic, thermosetting and thermosoftening. In the production of a thermosetting plastic, as more heat is applied, a cross-linking reaction occurs. This is where different polymer chains bond to each other. When the reaction is finished, the resin is set, so it can't be softened or melted by heat and pressure, or dissolved in a solvent. Therefore, these plastics can't be recycled. Thermosoftening plastics are much more easily recycled, and their different melting points means that they're fairly easily separated. This is explained later in the presentation. These 7 plastics are all thermosoftening, so could be recycled. But what are they? Polyethylene terephthalate, used in fizzy drinks bottles and oven-ready meal trays. High-density polyethylene, used in bottles for milk and washing up liquids. Polyvinyl chloride, used in food trays, cling film, bottles for squash, water, and shampoo. Low-density polyethylene, used in carrier bags and bin liners. Polypropylene, used in margarine tubs and microwavable meal trays. Polystyrene, used in yogurt pots, protective packaging for electronic goods, and in egg cartons. And other, which are any other plastics that do not fall into these categories, such as melamine, used in plastic plates and cups. All of these plastics are potentially recyclable, although as mentioned, only some are actually recycled. So here's what happens when we recycle our plastics. We put them into separate containers like these ones. A lorry like this one takes them away to a factory like this one. This is Redcar in Teesside. Later we'll be discussing whether the fuel costs of the factory and the transport used render the whole process pointless. Recyclable thermosoftening plastics can either be recycled back to their original monomers by extreme heat and pressure, or simply back to their original polymer properties. One method of recycling is really better termed reusing, such as reusing our plastic carrier bags at supermarkets, or reusing non-recyclable thermosetting plastics. Shown is how the recycling process is carried out in practice. First, the plastic is inspected for contaminants, such as glass, and for plastics that the plant doesn't recycle. Then the plastic is washed and chopped into small manageable flakes. The plastic flakes are put into a flotation tank, where some sink and others float. Now they are partly separated. These flakes are dried in a dryer, in different compartments depending on their weight. The dried flakes are fed into an extruder, where heat and pressure melt the plastics. As different plastics have different melting points, the plastic types are further separated here. The molten plastic is forced through a very fine screen to remove contaminants. It is then formed into strands. These are cooled in water and chopped into pellets, ready to be sold to manufacturing companies to form new plastic products. If you've got epilepsy, I'd look away. These are just a few of the many, many things that can be made from recycled plastics. Or perhaps more interestingly, does it save energy at all? Looking at tens of sources, both electronic and written word, it seems that we don't really know. Sources suggest that recycling plastics uses between 10 and 200% of the energy that would be used if forming the plastics from scratch. It seems that there are just too many variables for a general answer, and that it depends on things like the distances the lorries cover, the distance that we have to travel to recycle it, as there are still some people without the service of having recycled plastic collected from their home, how efficient the recycling machinery is, and whether the plastics have to be separated into their different types by a machine, and or from glass, as many recycling points still have plastics and glass recycled together. Therefore, a general assessment of the situation is still quite hard to make. Regarding the distance travelled by the lorries, of course normal waste lorries are not used, so an extra lorry is required, leading to a greater carbon footprint. Some suggest that we could just burn the plastics for energy. But these would still need separating, as plastics like PVC release toxic fumes when burnt, as previously explained. As also previously mentioned, it also depends on the type of plastic being recycled, as although it might be worth recycling PET, recycling light bulky polystyrene would be much less efficient due to the higher transport cost to plastic weight ratio. My view on the saving of energy when recycling plastics is that it isn't as important as hindering the decline of sources of non-renewable oil, and keeping non-biodegradable plastics out of landfill sites, as some can take up to half a millennium to decompose. These are surely two of the main reasons why we started to recycle plastics in the first place. I suppose it's time to whip out my cling film and wrap this presentation up. Here are a few pros and cons of recycling plastics. Oil is a non-renewable source, and by recycling plastics, we are slowing down the rate of decrease of this source. We can turn recycled plastics into things that we actually need, rather than them clogging up landfill sites for up to hundreds of years at a time. We've gone over the energy debate, and whether this proves to be a pro or a con for this energy argument is yet to be seen. With the recent and ongoing rapid increase in the recycling of plastics, I'm sure that we'll know the answer to this soon enough. A commonly expressed con of recycling is the effort required. The rubbish bin to recycle bin ratio on most streets and businesses is not good, meaning that to recycle, you may have to hang on to that empty plastic bottle for longer than you choose to. However, you could argue that those suggesting this are just lazy, and that it doesn't mean recycling shouldn't be done. Michael Collins at the environmental consultancy ERM has said that the difficulty is when you are using recycled plastic as a replacement for a different material such as timber. The embodied environmental impact in a piece of timber is lower than that of virgin plastic, so you are not getting the same benefit. The most serious problem with plastic waste is to do with additives such as colorants and stabilizers in the plastics, which often contain toxic components such as lead and cadmium. Researchers don't know whether such additives are released into the environment during the recycling process, as they would be if left to decompose in a landfill site, suggesting that with regard to protecting the environment from these toxins, recycling may be pointless anyway. By recycling plastics, though, we can reduce the current level of them in landfill sites, which sources suggest is around a fifth of the total waste. For more information on plastics, and to see some of the main sources that I used to make this presentation, please see the information box. Thanks for watching. I'm Jamie Lyons, and this was a short presentation on the recycling of plastics.